Good afternoon, everybody, and welcome to this EECONE webinar on a digital product passport for electronic products. My name is Carolynn Bernier, and I'm the host of this webinar, and thank you so much for your attendance. The goal of this webinar is to understand what is the current status of the deploying DPPs for electronic products, and what are the practical use cases, and to discuss future outlooks. Before we start, I would like to invite Moritz from Infineon, who is the coordinator of the EECONE project, to briefly talk about, introduce the EECONE project.
Thank you very much, Caroline. Also, a warm welcome from my side. I'm very happy to join this webinar. We are the EECONE project, and we are all about e-waste reduction. So why are we doing it? The amount of e-waste that we produce is increasing and increasing, and unfortunately, the recycling rate is not keeping up with that. So therefore, we want to tackle this challenge. And we are a big consortium, actually. We are 49 partners from 16 different countries. We are approaching now our third year, and we will end the project at the end of this year, actually. We are guided by the 6R principles. So obviously, we try to reduce, we improve the reliability. We want to make repair possible and affordable. We're looking into reuse cases. We want to refurbish and nevertheless also recycle if that's the end of life have reached. We are looking at three attacking vectors here. First of all, we want to manage existing e-waste. So this is something we cannot change at the moment with our developments, with new electronics, but we want to also have a look, okay, how can we recycle it and what can we do about it? Then our second vector is the design of environmental sustainable electronic components and systems. So how can we help developers? What tools are missing, and where can we really improve design workflow? Then, last but not least, we're also looking into new technologies to boost circularities and decrease the electronic waste. So, for example, we are looking into less copper on PCBs. We are looking into reuse of components. We are looking into new inks to print electronics. And this comes all together in 10 use cases where we can see tangible results. These use cases range from automotive, with Bosch and Vitesco, for example, to consumer electronics, where the Danish Institute, but also Formod is trying or is developing an eco-designed remote control unit, to also household goods. Then another field is healthcare, where we look into making one-time use medical sensors more sustainable with recyclable and biodegradable materials. We're looking into communication technologies, where we will also share this week a nice video from Thales and UC Louvain, where they showcasing, okay, how can we reuse a smartphone and make it transfer it into a router and allow a second life for that. Then we are also looking into aeronautics. How can we develop airplane wings in a more sustainable way with printed sensors? And last but not least, we're also looking into agriculture to monitor the fields, to make the life of farmers easier and save resources there as well. And today we are talking about the digital product passport and how it can help us here to reduce the e-waste. And with that, I hand over again to Caroline.
Thank you, Moritz. So in today's webinar, we have many speakers coming from different aspects of the supply and value chain. I'm going to, rather than to read them off, I'm just going to illustrate how each of these speakers, what is their context and their position in the supply chain and the value chain for electronic components and products. And so I'm going to start off with a kind of an introductory presentation to talk about the DPP and how it relates to the European DPP, which is mostly about compliance to EU regulations, but really the digital product passport is much more than just complying to European regulations. So, and then Chiara is going to make a presentation where she's mostly going to talk about the European DPP, which comes into being when a product is placed on the market by the responsible economic operator. And this is where the European DPP comes to life and hopefully is used to make the products, extend the product's useful life downstream in the value chain, more or less. Then Catherine from the Responsible Business Alliance will present a DPP-related data information sharing initiative using standards currently being developed by the UNECE. And here the focus will be on traceability and transparency of product-related information and facilities-related information over the entire supply chain. Then we will have a presentation by Harris from Semiconductor X, which is developing product DPP and product-related interoperability mechanisms specifically for the semiconductor value chain, so supply and value chain. Then we will have a presentation by Marc, who is really very much downstream in the value chain with the DPP solution by Data Peanuts, which is focusing on PCBA and component reuse downstream. And finally, we will have a presentation by Francisco from the IPC, which is a standardization body for electronic components. And here the focus is on standardization for everything that we've spoken about previously from the entire supply and value chain. Okay, so in brief, this will be the content of this webinar. And the reason I decided to organize this webinar is because all of these different actors were not necessarily aware of the work that was provided by the others. And so the goal of this objective is to, first of all, bring together many DPP-related activities in the electronics sector to make sure that we all understand what each one is doing and how all of this work complements the other's work, right? And fundamentally, what I would like to come out of this webinar is to discuss how we can better work together in the future for faster and more impactful outcomes. So I'm going to start out my presentation by showing how the European DPP fits into a global DPP context, right? So you may have heard of the European DPP. It's more or less a mandatory requirement coming out of several European regulations, not only the Eco-Design for Sustainable Products regulations, but many other European regulations. But the European DPP can also be used to share voluntary information in addition to mandatory information. And here, for the European Commission, the objective of the European DPP is better information for consumers, facilitating market surveillance activities, and also supporting the transition to a circular economy. But other than the EU DPP, there are many, many other DPP initiatives out there that are not necessarily that of the European Commission's. And in industry, what we see is that DPPs have been introduced for many years already in a voluntary way, because here they are used as a support for industrial innovation and often used in smart manufacturing contexts. They are used as a support for marketing, a support for better traceability, a better transparency. Sometimes they're used for anti-counterfeiting reasons or for also circular economy. But in a business-to-business type of circular economy objective. Then you have another DPP from the United Nations. So the United Nations Transparency Protocol, they have defined a DPP standard. It's a voluntary DPP standard. And here the objective is to better traceability and environmental, social, and governance information transparency. In the United States, the DPP is being introduced through a project of the Customs Border Protection. And here the objective is making customs more efficient and reducing costs here, and also better supply chain intelligence. But there are DPPs in other places of the world. In Korea, for example, they are considering a Korean version of the ESPR, which might be stricter than the ESPR, focuses on extended producer responsibility, access to EU market, administrative burden reduction, and circular economy. And there are multiple DPP initiatives in China, and they have advanced very fast, already publishing criteria for the evaluation and certification of DPP service providers. And here, the objective is really to feed into the digital China strategy that includes traceability, a circular economy, industrial efficiency, also access to the European market, and e-commerce traceability. In Vietnam, here the focus for consumers is quality of products and conformity and product traceability. Turkey is essentially in a European alignment mode. And just this is my final slide. In Japan, the focus is more on industrial efficiency and international data sharing. And you will hear often the term material passports. So usually material passports are voluntary digital product passports that describe materials or chemicals or components. And they're often introduced for innovation reasons or for supply chain transparency and data sharing reasons. You will often hear the word DPP to refer to more or less anything. Financial assets, the DPP, services DPP, all sorts of things. And the reason for this, it's the DPP is quite a convenient term, right? Because it can be applied to just about anything. And this is because of the DPP paradigm. And I'm just going to very briefly explain what I mean when I say the DPP paradigm. So suppose I have two actors and they want to share data, right? And actor two wants the data that actor one is making available, but they have no pre-existing business relationship. So there's basically two ways you can go about that. You can either, actor one can push their data to some data exchange platform, and actor two can come and get it from the platform. That's the classic platform approach. And the DPP paradigm is that there is no platform, and actor two comes in and makes a data pull request from actor one, who has made the DPP available on their system. Okay, so that platform approach is a centralized approach where, of course, you're paying for this service most likely, whereas the DPP paradigm is a decentralized approach. So what the platform does usually is they impose what the data should be shared and the format it should be shared in. And this creates, by definition, a data silo, and it gives a lot of control to the platform. But in order to avoid this, actor one must provide their data in some interoperable format so that actor two can actually make sense of the data and reuse it. But actor one remains sovereign over the data. The issue with platforms is that, well, there can be many, and therefore, since each one is a data silo, each one requires specific data, specific formats. So as many platforms you may have, the more silos you may have, and this can create issues for the actors who want to share data, especially those who have to provide the data. But in the other approach, well, of course, actor one has to assume the cost of making the data available in some interoperable format. Okay, so it doesn't come for free, of course, this interoperable format. Actor one has some work to do to avoid this approach. Now, what if they want to share confidential information? Okay, so this is where platforms are very strong because they offer the management of access control with their users. And managing identity and access control is very costly. Okay, so this is where platforms are very useful and strong. If you're in a decentralized system, that means actors one and two must sign some kind of contract, and actor one has to assume the cost of managing the identity and access control for all actors requesting the data. Okay, this could be very costly. Or actor two has some form of trusted digital identity for identification and authentication with actor one, and this could be done either using a data space or using a business wallet. Okay. So, in summary, Today, we live in a digital world that are managed by platforms. These are very powerful because they manage the cost of identity and access management. And another issue is that very few people actually understand what interoperable data is in the first place and what is the cost-benefit ratio with the issuing of interoperable data. Also, it's often easier and very low cost to delegate to a platform. And finally, many IT companies earn a living solving data interoperability problems, right? So to summarize what I mean by the DPP paradigm, it's about sharing interoperable data in open and decentralized ecosystems. Okay, just to finish up this very brief introduction to what is a DPP, I'm just going to just briefly cover what are the main components of a DPP system, and this applies to all DPP systems, including the European DPP. So a DPP system basically starts with a UID, a unique product identifier that must be globally unique. And global uniqueness means two things. It means there's a single identifier, not two or three, and that identifier is unique in the world. Okay, that's what globally unique identifier means. And this is the starting point for all DPPs. Then this globally unique product identifier must be embedded into some kind of a web link. Okay, and this web link is made available through a data carrier, which can be a QR code or a data matrix. It could be an NFC tag. It can be an UHF RFID tag, in which case, most of the time, I don't have a lot of room on the chip to embed more than 96 bits, 96 characters. So that means the web link has to be obtained through some kind of resolving system, okay? But in both cases, I have, at the end of all this process, I have a UID-enabled web link. I use this web link to access the data, most likely through some other type of resolver, and this tells me where to retrieve the data. And this data is stored in a decentralized way. It's not stored in a centralized database somewhere. It's stored under the control of the economic operator that is providing the data or under the control of their appointed DPP service provider. Okay. And then, of course, if I'm a consumer, I can scan the data carrier and retrieve the data, or if I'm in some form of B2B data ecosystem, then I may have access to the industry resolver to obtain the link. And fundamentally, in the future, these data carriers here, they could become entirely virtual. So if we have some AI mechanism to uniquely identify individual items, then the data carriers itself can disappear. Once I actually retrieve the data, well, what is it? Well, it's itself, it's a JSON or JSON LD or XML file, right? It contains structured and machine readable and interoperable data. And what the consumer will retrieve will be a human rendered version of this data that's most likely embedded into some kind of HTML web page. Okay. So I'm done. I'm through with my presentation. I will give the floor to Chiara. So the goal of my presentation was just to give some basic information, some background, so that we all have the same starting point. So Chiara, I'll let you share your screen.
Yes, thank you, Carolynn. So normally now you see my screen.
Yes, all good.
So what I want to do with this presentation is to present you a couple of studies we did on DPP development for electronics. Actually, here I have quite a double position because I participate in EECONE. So you had the presentation of EECONE done by Moritz. In EECONE, I co-lead the research direction on the sustainable development of electronic components and systems, but I also participate to the project CIRPAS2 led by Carolynn, which is focused on the digital product passport. The two studies I want to present here on use cases and on the drivers, barriers, opportunities, and challenges have been done in CIRPAS2. Thanks to an expert working group on electronics I'm moderating, and I see some of the experts in the audience. So thanks for participating. The first study is to present what are use cases for DPP for electronics. So when we speak about DPP use case for electrical and electronic equipment, I refer to an electronic or electrical product or component on which a voluntary DPP is applied. It is important that to highlight that we refer to voluntary DPP because there is currently no regulatory DPP for electronics right now. I mean, we have the ESPR, which speaks about DPP. We will have a delegated act for all sectors. So here we speak on textiles, on construction materials. Actually, we have no delegated act for electronics. So this study on use cases is done on a voluntary DPP. We investigate 3 levels that are the level we find in the ESPR, item, model, and batch level. The item refers to a single, uniquely identifiable physical product. Then the model refers to a type or a design, and the batch refers to a group of items manufactured together under the same production conditions. We are considering electronics, so we are considering complex systems. We can apply DPP at different granularities. We can have a product, system, PCB, or IC granularity. The product granularity refers to the complete finished product that is sold to the customer. Examples are a laptop or a smartphone. At system granularity, we have a measured functional module within the product consisting of electronic components. We can think as examples a storage system or a wireless communication system. Then we have the PCB granularity that represents an individual printed circuit board within a system or a product. And finally, the IC granularity refers to an individual integrated circuit mounted on a PCB. We are trying to collect the use cases on DPP. This is one of the actions I wanted to do since the beginning with the expert working group on electronics in CIRPAS 2. And then we found that other projects wanted to do the same thing, in particular during the DPP for EU conference. The project Face DPP presented this idea of collection of use cases, and they presented a framework for the DPP use case assessment that can be good to collect the use cases. So we decided to create a cross-project collaboration. So among the various projects working on the DPP, we have Face DPP, CIRPAS 2, CRISE, and other projects. And we are doing interviews based on the DPP use case assessment framework presented by Face DPP. We want to have such a landscape of DPPs in electronics because we wanted to identify the product scope on which categories at which levels we currently have voluntary DPPs that are developed. We want to identify the use cases with the most relevant footprint, which circularity strategies are the most effective, and the requirements for future policies. So here you see a general vision of the framework we are using. I'm using to drive the interviews, and the other projects are completing also this framework for their use cases. So this is a work in progress. I can present some preliminary results on some of the interviews I did with the EFTER working group of electronics of CIRPAS 2. So some examples of use cases on which we have application of DPPs are the PCB cards, circuit breakers, skincare devices, professional displays, heating, ventilation, and air conditioning systems, control cabinets, white goods, and a computer. And we also have people, of course, working on the different DPPs, but for the same category of products. For example, for the white goods, we have different people, different companies applying DPPs for a white good. This is why we find two levels. Some of the people apply the DPP at the model levels, at other at the item level. We tried to identify what are the economic and environmental impacts for the application of the DPP. So we asked to the participants what were the environmental problems to be solved and what is the expected economic impact, and if they quantified these impacts. For the moment, for the interviews at least done, for the moment, we have no quantification, but we have a qualitative evaluation. In particular, for the environmental problems to be solved, the participants identified that we need environmental information about the products, the product carbon footprint, which hazardous substances are in the product, the recyclability, and the end-of-life impacts. Then there is a need for traceability and transparency across the life cycle. There is a need to reduce waste from printed manuals, so we can exploit the DPP to avoid all the printed manuals, sometimes also in more languages. Support of repair and circular strategies, and the support of environmental certifications thanks to the DPP. As for the economic impact, the participants saw a potential reduction in errors through better supply chain visibility and optimization, the reduction of documentation costs. This is linked to the environmental problem on having too many printed manuals. There is a support of other markets, so the possibility of creating and supporting new markets, especially second-hand markets and product as a service models. And the participants see a potential competitive advantage. So as Carolynn said before, the DPP is much more than compliance to regulation, and it can be exploited by companies for an advantage of their products with respect to products without DPPs. Then we have further feedbacks on what are the most relevant stakeholders implied in the DPP for the use cases we collected so far. Here, the participants identified raw material suppliers, manufacturers, and distributors, the DPP service providers, EU authorities, and the consumers. This is a partial view because we didn't, we still don't finish to collect the use cases. We asked also to participants what are the regulatory information requirements that can be needed when there will be a regulation on DPP for electronics. They asked to have information in the DPP about the bill of material, the energy consumption, the repairability, recyclability, and also a link to the user manuals. Standardized repairability, recyclability, and circularity indicators. The possibility to have an eco score for environmental performances, and a clarification of supply chain responsibility. Then when we ask what hinders now voluntary information exchange without the DPP system, why we don't have more voluntary DPPs, there is quite an agreement among the participants that normally industry doesn't want a voluntary information exchange if there is not a mandatory enforcement. The main obstacle is that the business model is uncertain, and industry normally doesn't want to go to an additional process and a cost for DPP if the business model is not proven. So if there is not an economic impact of information exchange through a DPP or like DPP system. And finally, we asked for the additional innovations needed to implement DPP for electronics. We find some topics that are currently ongoing, especially in research about interoperable DPP architectures, blockchain or anti-copying mechanisms, auditing frameworks, and a clearer technical guidance. So this is for the first study. A second study I want to share with you is something that is finished. It is about the identification and ranking of drivers, barriers, opportunities, and challenges of DPP for electronics. Here we built on a previous insight from a fourth project, CIRPAS, that identified already these drivers, barriers, opportunity, and challenges for DPP more in general, because CIRPAS considered also other sectors like batteries and textile. Here we took these elements identified in the first study, and we built on these previous insights while capturing the needs and the perspective specific of electronics. So we speak about the presence, so the drivers and barriers. The first study identified the 10 drivers and the 28 barriers. And we speak about the future with 32 opportunities and 30 challenges identified in the first study. The expert working group participated to this survey. We have various representatives of various actors in the whole electronics value chain. So we have component manufacturers, design houses, research organizations, DPP service providers, and so on. You can find all the results on a white paper available on Zenodo. You can see the link at the bottom of this slide. Here I just want to present the top 3 of each element. So for the drivers, we find the mostly the same elements that we also find in the interview. So the main driver is a regulatory push and pull effects. Then we have a high demand for user data and informed decisions based on comparisons. As for the barriers, the main barrier is due to the complexity of the value chain. So it is particularly true for electronics. Missing data from international actors outside the European Union and the unclear financial benefits. This is also an element that we can find in the interviews. As for the opportunities, the first one is about providing information on the material composition for recycling, enabling new business opportunities and scaling up circularity. And finally, for the challenges, the fourth challenge is to ensure data quality. Then there is a lacking trustworthy data and dependence on other value chain actors, and aligning relevant regulations with non-European governments. I conclude my presentation with the current status on legislations. So up to now, we spoke about voluntary DPPs because there is no regulatory DPP expected for the electrical and the electronic equipment, at least for the short term. Our current reference is a working plan. It is the Eco-Design for Sustainable Products and Energy Labeling Working Plan 2025-2030. It is a document published last year. Here we can see two horizontal requirements that may be applied to electronics. The horizontal requirements are the repairability, including scoring, and the recycled content and recyclability. Stakeholder meetings are currently ongoing on the horizontal requirements, and you can find the details and the progress on these requirements online on the website of JRC, for example. And in the working plan, you can find 16 energy-related products that have been identified for eco-design requirements or energy levels with an adoption expected until 2030. So I conclude my presentation here.
Thank you, Chiara. Thanks a lot. Now I will give the floor to Catherine from the Responsible Business Alliance. In principle, you should be able to see my screen now. Catherine?
Yes, I can see.
Super. Thank you.
All right. Hello, everyone. Thank you so much for joining today. I will provide some limited remarks, as Carolyn mentioned, around kind of jumping off some of the, particularly on the last points there, around some of the drivers, opportunities, barriers, and challenges around DPP, how the RBA, the Responsible Business Alliance, has been approaching this. So I'm going to provide a little bit of information, particularly around some of those foundational end-tier traceability challenges and the approach that we are taking within our organization in the electronics industry. So we can go ahead and go to the next slide here. For those who are not familiar with the Responsible Business Alliance, we are the world's largest industry coalition dedicated to responsible business conduct and global supply chains. We have a broad membership concentrated in electronics, but also across multiple industries that source electronic components, such as consumer products and goods, retail, automotive, aerospace, and other industries as well. We are structured as an overarching organization with RBA, with our code of conduct, with a range of assessment programs that we offer in the value chain, as well as resources and tools to support our company members in navigating supply chain due diligence and environmental sustainability challenges. We do have particular initiatives that sit under our organization structure, including the Responsible Minerals Initiative, the Responsible Labor Initiative, the Factory Initiative, as well as the Responsible Environment Initiative. And across both the RBA as well as all of our component initiatives, we have over 600 company members with combined annual revenues of greater than 8 trillion. So we've been engaged in the electronics sector for quite a while, and we have a pretty broad range. I believe there are probably several companies on the line today that whether you are the main contact point or another team within your organization is, you may be a member of the RBA or one of our initiatives. And on the next slide, you can see just a high level overview of, just this is the logos of organizations that are part of our membership that we've been engaging with over a number of years on shared challenges in the supply chain. But we don't need to dwell here a little bit too much. This is just to provide an overview on who we are. So I'll pause here a little bit around, how RBA comes to the broader data challenge. What are the kind of issues that we are trying to solve, and as an industry collective in the supply chain. We've been involved in broader challenges around supply chain data, and particularly what that means for building an end-to-end view of the global supply chain for many years. First approaching this within the Minerals Initiative, but that has certainly grown and expanded over the last decade or so to be very heavily concentrated as well, and a focus in the manufacturing space. As a result, we have a lot of experience, both as an industry collective, but also with our individual members, approaching different ways of trying to develop end-tier traceability in their supply chain to identify everything from what are the specific mines of origin for particular minerals that they're using in their supply chain, to understanding what are the kinds of environmental and social conditions that are taking place in the midstream of their supply chains, to even just plausibility around material movement flows throughout the multiple layers of the supply chain. As was mentioned by Chiara, that they chose, but it just shows at a high level what is the type of information that is assigned. It goes back to a facility ID, which is where the unique identifier would slot in, information about their location, processes, a little bit about the declarations, and that's the digital conformity credentials of supporting different claims about, at the top, something that is published by RBA. The RMI does conduct assessments, but also that is hosted by the RBA and attached to a facility record. And then the example of a conformity credential that supports different claims about sustainability at this mine, that is not conducted by the RBA, is not hosted by us, but can all be linked together as part of a unified digital package that site can use to collect and report information once about themselves, and ultimately link back to the issuing authority. If we go to the next slide, we can see then what this looks like. We've spent, albeit a lot more time to date, on digital facility records on the end-tier traceability use case, but this goes a little bit into showing how this ultimately then works on the digital product passport site. And again, this is very high level. This is an example of one digital product passport that we've mocked up, played around with as part of different pilot activities that we've pursued. This of copper cathode, and just, there is a limited set of information that has to be in the digital product passport in order to exist and as a functional credential, but there is a lot more information that can be added in here. The schema provides a lot of flexibility and is designed particularly to make sure that the information on a product level that is needed for different regulations, whether that be the EU batteries regulation or other market conditions or other relevant commercial data about a product, can be included. This is, again, just an indicative example of one product passport that was generated based on what one South Korean refiner felt was the most material information to generate in a product passport about themselves. And this shows then how it links to the facility record that was generated as well. And we can go to the next slide. And this also shows where the digital conformity credential and the digital traceability events would also be linked in at a product passport level for these. An example here, and one that certainly comes up a lot in our membership and where we'll be spending more time in the coming months, is around recycled content declarations at a product passport level, knowing that's not the only thing that's important, but it's certainly something that comes up quite a bit, particularly but as it pertains to copper for our membership at this time as well. We can go to the next slide. As I mentioned, the RBA did conduct a collaborative industry pilot, which brought together 25 organizations from across the electronics value chain to really test this protocol against the challenges that we know exist for end-tier traceability and data sharing on both a business and a technical level throughout the supply chain. We did focus in on actors that were operating in the cobalt, copper, and lithium value chains, and ultimately are part of the battery value chain. We did generate real data credentials, but using synthetic data for the upstream and midstream supply chain sites. And you saw some of those screenshots in the prior slides. And we had a lot of robust roundtable discussions to test these, to figure out what needs to happen next. But ultimately, very pleased to report we did get a successful proof of concept that this data protocol approach, the flexibility that it offers, the core principles around verifiability, and the interoperability that it would fundamentally enable across different systems would meet different actors' needs to ensure that they can convey the information that is important about their products while being able to protect data that is either sensitive for their product or needs to be disclosed to different actors in different degrees. And at a high level, this is just to capture what are we doing next. And we certainly invite anyone that is interested in learning more about what the RBA is doing on the UNTP to reach out to me or to others on the line that are engaged in the UNTP as well. We are enabling some really lightweight tooling to, again, this is not a platform captive approach, but relies on a robust ecosystem of tools. And one thing that RBA always does for our membership and for the supply chain is provide lightweight tools that they can use if they so choose. So we are enabling digital facility record issuance. We have a digital facility record issuer that will be soon released, both for sites that we work with today as well as those that are not engaged with RBA. We also have a digital product passport issuer on the roadmap, but we have started with the digital facility records. As an organization in the second box here that itself conducts audits and has standards, we are also in the process of digitizing our standards to be issued in this format so that they can, as noted on previous slides, be linked to digital facility records. And we are continuing to digitize our noted mineral standards, our factory level standards, and we have a range of other tools that we have a roadmap to digitize throughout the rest of 2026. We are also hosting software vendors and technical teams of our members in different work groups to learn more about how to adapt the solutions that they offer today or their internal systems if they're at a company to be able to generate and exchange data that is aligned to this protocol. So I think that's the high level of a lot of things that we're doing, where this has taken us, and happy to. And yes, Carolyn, the slides can be shared out to the question that was raised in the chat.
Thank you so much, Catherine. I will now ask Aris to share your screen. Maybe I think you're still on mute, Iris. We can see your presentation. Everything is good, but you're still on mute. Now we can no longer see your presentation. Now it's good. Okay.
So can you hear me?
Yeah, perfect. Thank you.
Perfect. The WebEx screen disappears behind the presentation. So for the next ones, first unmute, then present. So hello everybody, thank you very much for the invitation. I'm from Semiconductor X, part of Manufacturing X, and from the company Expo 21. And I'd like to present you today the approach we have within semiconductor, how we want to share the DPP and what the DPP means for us. So first we start with something we call, it's a bit a German thing, we call it DPP 4.0. In order to make a slight difference between the regulative DPP and the possible extensions of the DPP. So we're very close to Catena X as well. And the project is founded by the European Union and the German Ministry of Energy and Economic Affairs. And how we see it, if you want, is that the DPP, the first step for us, it provides an identity for a model or an item. And it's actually the initialization of a whole growing tree, which comes as next is a digital twin, the data spaces. And on top of it, applications, thousands of applicators like sustainability, traceability, digital supply chain applications, digital value chain applications, and at the end of it, so-called digital products. As you can see on the left side, you see scan for DPP, scan for DMP. We try to make a little difference. Internally, we call DPP everything which is based on regulative demand and requirements. And DMP, we call it the non-regulated DPP, which is within the supply chain. So, for example, for incoming materials, where at the moment our chips may be considered as DMP eligible, but not for the DPP. We have, when we speak from the supply chain of semiconductors, we have to see that it's a bit different than, for example, the one from automotive. So it's not one up, one down. If we go through the building process of a chip, where we start on the left with a wafer, we go through the fab. At the end, you sort the wafer, you cut it in small dies, and at the end, you assemble those dies on chips and test it, distribute it, integrate it in PCBs, and operate it, for example, in a car for at the end, the recycling. But on the production level, we have always a chip designer who has quite involvement through the whole supply chain. So he's actually controlling his own supply chain and value chain, and doesn't work a bit different than the one up, one down principle, which give us some parts of it, make it easier, but give us some more requirements as well. When speaking about the DPP, we see on the left we start with a digital twin, where we have a lot of information as well internally within the company, as when we're exchanging those information through the supply chain. And with those things, you can include material data, sustainability data, circular economy data, but as well traceability, maintenance, and simulation data, where the simulation data are quite secret and IP relevant. So we start with the digital twin, then we reduce the amount of data and are speaking about the digital material paths, which we can exchange within the supply chain, ending with the DPP. From the discussion we have today, you can call all of it the DPP, but this difference between DPP and digital twin is the one we're doing within the Manufacture X project. And as you can see on the right, we have, for example, when we're speaking about the DPP, we see it as well as, if you want, an entrance to AI services. And AI services means that we were speaking about, let's say, human viewable page of the DPP. But we see as well that in the near future, you will speak with your DPP. So you will actually speak with the AI behind it to help you either to repair something, either to use something, or as well use the DPP as an enabler when we speak about digital product to enable the so-called smart digital products. So the unique identity gives you your credential to access AI services. And on the bottom, you see that when we go through the supply chain, we see our digital material path, which can be represented through an asset administration shell. It's at the moment very German, but as well ESC supported format of a digital twin. And on the right, we end with a DPP, which will be the car in itself, or in a car, for example, the battery or the train components. So I was speaking about the data space. So what we're doing is actually we are working on the manufacturing projects to share information through a data space. And what is this invention of the data space and the data ecosystem? We say as well always that the data space is like the invention of the railway. So the asset administration shell, which is a digital twin format we use to exchange data, including the DPP, is like the invention of the container. So we can say in our discussion as well that the DPP is like the invention of the container. And what's very important, what we saw last, is that we not only speaking about data interoperability, but as well about process interoperability. So we're discussing about so-called kits, which are use case kits, which is not only for circular economy, but as well, for example, for demand and capacity management and so on. And those are so-called process interoperability. What was done in the 60s by the aerospace industry make it possible to land an airplane worldwide at any time on a brief stamp. At the end, we have cybersecurity. The DPP and circularity is part of those projects, and this is enabled for thousands of new AI businesses. So to exchange the DPP, we're developing in manufacturing. I will show you in the next slide what is exactly. We developing so-called data spaces with a single point of connection, which is the EDC, Eclipse Data Space Components. And this makes it possible to use one connector to exchange whatever information you want in the supply chain in form of digital twins. And it includes a security framework. And it is a so-called peer-to-peer connection supported by an operator, but it stays peer-to-peer, so it's a federated environment. And those manufacturing project is an initiative of the government in Germany, where you have different projects inside, like Catena X for automotive, Constructive for construction, RoboX, Aerospace X, Wind X, Chem X, Energy Data X, Railway Factory, and we are in Semiconductor X. And all share a common ground, which is identity, a common identity, which we go for ADAS 2.0, a common data exchange protocol, and a common data semantics, and so-called common kits for process for interoperability. And everything we're speaking about, you will find that in the Eclipse Tractus X, where you see, for example, here is the example of the EcoPass kit for the DPP. We're exactly describing the adoption view, the software development view, operating view, success stories, exact protocols, data payloads, and sometimes even software architectures. So we're trying actually to build a common basis. One interesting point that we're working on is on an opaque encrypted identifier for the DPP. So the identifier does not give any information about the number of products you're producing from a batch or from an item, in order not to divulge with information which are financially relevant. Use cases. So our use cases, and I'll go fast through it to save a bit of time, in Semiconductor X is that you see on the left the manufacturing use cases coming from the DPP, which is carbon footprint and universal identification. So the DIT, the regulatory conformity evidence, and the material tracking. And on this right side, you see the bridge to the digital twin, so enhanced use cases, which can be done based on the DPP, but which are not triggered by regulative requirements, is, for example, backward traceability through supply chain, lot and batch genealogy, yield and binning classification, quality reporting and process provenance. On the supply chain side, we have, for example, on the left side, DPP use case like geographic origin transparency, trusted supplier status, and counterfeit risk scoring. And on the right side, again, tamper-proof event logging, which is actually much more into additional values possible. Within the life cycle and operations, again, on the left side, what the DPP can offer, one of them very interesting is entitlement. We can combine the identity of the DPP it's something what SAP showed us in the use case, to entitle the use of software elements, for example, in digital products and licenses. And on the right side, again, with the digital twin, so an enhanced DPP, we can see the product history, upgradability of the product, monitors the OTA updates, so over-the-air updates of the software elements of a product, so keep it cyber secure. We can monitor that. We can monitor replacement of software or chip component, and enable so-called maintenance and remote maintenance. And from a circularity point of view, end of life, You have the universal identification, so to see which products goes end of life, compliance with regulation, critical material recovery tracking. So is it lost somewhere in the worldwide, let's say, black market, or did we really recover those materials? And on the right side is additional use cases like decommissioning guides, reuse eligible declaration, recycling intelligence. And recycling intelligence is quite interesting because you could, for example, offer incentive to get your products back if they have valuable materials inside or components you can reuse, which is something we don't do in the chip industry at the moment, but it's done, for example, in the automotive industry when you can give back your brakes, and those brakes are refurbished and rebuilt in completely new cars. And finally, interesting that it not only the whole concept of DPP and data space would enable a backward traceability from a car when you scan the DPP back to a wafer through the whole supply chain, which make it possible, which is quite important with automated driving. So if we have a defect component, we don't have to replace it in 2 million cars or 200,000. We could allocate which wafer has a problem, which dies around, so which chips around the defect one could be defect as well, and could end by replacing the computer only in 20 cars and not 100,000 or millions. So that was it from my side. Thank you very much.
Thank you so much,
And I
Harris.
give over.
Oops. Can you hear me? Thank you so much, Harris. I have 100 questions for you, but I will give the floor to Marc, Joussé. Marc, can you share your screen, please? And you have questions, Harris, waiting for you in the chat if you want to answer. Fantastic. Yeah, Marc, you're still mute.
Oh, yes. Sorry, I was on mute. So, hi everyone. Happy to share our works on the DPP and use cases. And thank you, Carolynn, for the opportunity. So, yes, okay. So let me introduce who am I and the companies. So we are a French family-owned group, and today I will talk only two companies. The first one is Retronix, and so we are recovering components for more than 30 years. We also repair boards, and we are a lab for analysis and testing of components of ICs. So it's our proven and industrial process foundation to talk about DPP. And 2 years ago, we created Data Peanuts, and it's really focused on data and how we can provide data for the electronic components. So I'm talking about the DPP. We are mainly talking about the data we can collect during the testing and analysis of the component in our lab. So why we care about the DPP? So two practical use cases. We are repair, and when you need to repair a board, you need to document the board preliminary. This is to diagnose the fault and repair the board at the end. If we are talking about the component recovery, to recover component, the number one issue is sorting better at collection. So that's why we think that players in charge of the electronic waste must have the right information available to sort the board and better valorize the component. And I like to say that even when mounted on a board, a component remains a strategic asset. So we have this funny picture. present that. Let's talk a little about the context for the supply chain. First, talking about the environmental challenge, I like to show this this document from Fraunhofer. It's the Fairphone life cycle analysis, and the conclusion is that more than 50% of the environmental impact come from the board, the PCBA, and mostly the component on this PCBA. So we are not talking about the battery, we are not talking about the screen, but really about the PCBA. And today also, as European, we become spectator for the global supply chain. So the CHIP Act was a good step, but it's nothing compared to the US and Chinese investment. And we rely too much on these two big actors for the global supply chain of components. And also because we are working a lot for the defense industry, aerospace industry, it's important to say that the leading industries in Europe, they have programs with long lifestyle. Sometimes we are talking about 50 years, but these programs, they rely on a component with life cycle getting shorter. So we are talking about two risks: obsolescence, shortage, and building a circular economy is an opportunity for us in Europe. I don't say that this is the only tool, but it could be a tool in the future to become more. Sorry, I forget the word in English, but more stronger facing this challenge. So our vision for the DPP, talking about component recovery and board repair. So thanks, Chiara, to remind the granularity, talking about system, from system to ICs. For me, the system, the end user interface is really concerned by the DPP regulation today. For board, PCBA, it's different. I think that it's an interface between industrial player, and we have no interest in disclosing information to non-expert users. But even if the right to know is essential, we have a goal to deploy a DPP as an added value. And the challenge is valorizing components, recycling raw material, and facilitate the repair of the board in Europe. So let's talk about use cases. The first one, it was for us to think about a DPP for component, and mainly when we talk about recovering of components. Just to give you an overview, we recover components sometime at the end of life of the PCBA, but the component still is still interesting for the industrial to re-enter the supply chain. So the DPP is an interesting tool to track every component individually and certify this component for the new life. So in the passport of each component, we can find the ID card. So it's mainly the data sheet of the component, information from the data sheet. Information about the life cycle. So when we talk about life cycle, it's flight hours, operating time. If we can recover the environmental condition faced by the board or the system where the board was installed, storage. Sometimes it's interesting to have some storage condition of the components, mainly if we are talking about component dormant stock component. And the performance, the third part of this passport, it's lab result. So we capture the performance at a given moment, and it can be after the recovery, but also the performance on the motherboard. And as Aris talked just before, this DPP and this unique identity for every IC is really interesting because we are touching two topics, which are the digital print and also the calculation, simulation of the residual reliability. And they are fascinating topic, and they could be boosted by this use case of recovery, because we can and this is our work today at Data Peanuts, to build a batch of data with these two level, which are and at the end we could start to simulate some residual reliability for components. And let's talk about the DPP for boards, because as I said before, we are a boards repairer. I think that for boards, it's not interesting to talk about a unique passport for each board. It's more an ID card, something easy to implement, and with one goal: to better inform the different actors during the life cycle of the board for repairing and also recovering at the end, recovering components. But also we have this interesting topic of urban mines and how we can recover raw material from board at the end of the life. So this passport, we could find information, guidance for repairing, or at least a maintenance contact, and also all the information talking about the BOM, strategic components, to identify this component, locate this component on the board, and also information about the PCB, the assembly. So for information, MSL level, alloy, and field, every consumable used during the assembly, which could be interesting to know when you need to repair, and also information to diagnose the board. So thanks for your attention. I hope it was useful, even if it was maybe a high-level presentation. So
Thank you so much, Marc.
I can stop sharing.
Thank you. And I know we're running out of time, but so don't hesitate to ask your question in the chat, and we can answer the question online. I will ask Francesco to share his presentation. Maybe Marc, you can stop sharing.
Okay, here we go. All right. You can see my screen.
Mm-hmm.
All right, good afternoon, and thank you for holding until this time. I know we're running out of time, so I'll try to keep it as short as possible. I have a lot to cover, so it will be hard. But let's start with, so we are the Global Electronics Association. We're formerly known as IPC. We have expanded our vision for better electronics for a better world. Our core mission is to promote industry growth and strengthen supply chain resiliency. So with regulatory requirements that expand globally and supply chains grow increasingly complex, the industry needs to move beyond just static documentation towards a structured, machine-readable data that can scale across supplier, customers, and regulatory frameworks. So with our 300 global standards covering design, manufacturing of electronics worldwide, developed and driven really by industry volunteers, we are driving a simplified approach to supply chain through base requirements, terms and definitions, and standardized data flows, covering materials, design, quality, reliability, test methodology, and digital manufacturing. The existing barriers today in jointly standardizing a DPP for electronics are there. You've seen it, you've heard of it just now from my other panelists that were explaining all these different barriers that we are looking into. There are so many actors trying to connect global supply chain, especially when they're all trying to speak the same language. This is hard. Nonetheless, we have been developing a framework and foundation necessary for building a global scale interoperable set of solutions needed, as we call building blocks, as Harris pointed out, or backbone of a future trusted DPP exchange scenario. So we started, and I chose to start with supplier declarations because it is really the source from which all data is ingested and the basis for reaching compliance. So electronic supply chain facing this unprecedented compliance demand from the REACH, from ROS, from emerging ESG reporting expectations, incoming delegate acts affecting manufacturers across the world. They must demonstrate compliance across hundreds and thousands of components. So PDF declarations and email exchanges cannot be scaled, and the industry needs standardized machine-readable data that flows seamlessly. Interoperability is key here. So looking ahead into digital product passports, circularity reporting, and all other product-level carbon footprint requirements, we need to make sure that that is the basis, that is interoperable between all the different actors that are developing solutions. So when supplying into the EU, ROS, REACH, and SCIP are an optional. Conflict minerals due diligence is an optional. ESG expectations from global customers are hardening into requirements faster than most people anticipated. The 1750 series of 5X family follows a modular architecture. So 1751, first published back in 2010, provides a generic requirement structure. It's the envelope that defines trading partners, products, and request details. Think of this as kind of the foundation that holds everything together. The sectional standards like 1752, 53, 55, and 57 define specific data sets that can be transmitted within that single envelope of 1751. So a single 1751 envelope can contain multiple sectional data sets, allowing you to address materials, lab reports, conflict minerals, process chemicals in one structured exchange. I will not cover or mention further today 1754 or 56 or 58 because of the fact that those standards are no longer maintained by task groups behind them. And they do remain out there and remain as XML schemas. But remember, IPC standards are driven by industry. So when industry has a common goal, a standard is maintained and supported. Not to say nothing wrong about these standards, they're perfectly acceptable, just the new set of standards coming in that has been published on year 25 and now in 26 are on JSON, and these are the ones essentially 52, 53, 55, and 57. There's also a competitive angle here that a lot of people tend to underestimate. When two suppliers are comparable in price and quality, the one that can demonstrate digital maturity and can provide a clean, validated, structured compliance data with minimal friction will win the business. That is real differentiator today in global supply qualification. So the 1750 series data structures you build for compliance today are the same foundation that will power those next generation requirements that everyone's been talking about, because this has been probably more than 2 billion or 2 million, declarations so far over the past 10 years where using XML. Now with the new JSON schemas are far richer, and I will explain why. Now, the 1751 is designed, it's the generic aspect of the modular family of standards. Establishes three core elements: business information, who is providing the declaration, product information, and share the data structures like declarable substance list and query list that are reused across all 1750 series standards. This consistency reduces duplication and ensures interoperability. 1752, this latest revision, Rev C, came out just a few weeks back. It offers 4 classes of reporting. Class A would be a simple query and reply to apply to instances in which customers only require a yes or no. Class B reports material categories. Class C provides substance categories, compliance at a product level, ideal for like ROS, for instance. And Class D is a full material disclosure, reporting substances at an homogeneous material level. You may mix these classes within a single file. So one product might use Class C while a subproduct uses Class D. The 1755, for instance, another example that I wanted to give is it manages responsible sourcing declarations for conflict minerals like tin, tantalum, tungsten, and gold, as well as other minerals and metals. It supports both US Dodd-Frank requirements in the States, EU regulations here, OECD, and due diligence guidance. Declarations can be scoped at the company level, product level, or custom defined, giving you the flexibility to meet any kind of regulatory or customer requirements. Now, why the committees have decided to go into JSON because of the richness of the language itself. When this standards family first started, declarations were documents. Then they became XML, which is a structured data in a machine-readable format. That was a significant step forward. But XML has limitations in a modern enterprise environment. It's verbose, it's harder to integrate with contemporary web APIs and cloud platforms, and the tooling ecosystem is narrow than what industry has built around JSON. So as of 2025 and 2026 revisions of any of the 1750 series that I mentioned earlier, they have moved to JSON. And this isn't just a format change. It's a strategic realignment with how enterprise systems actually work today. PLM system, ERP platforms, cloud compliance tools, supply portals, they all speak JSON natively. Standard JSON viewer can read the data, integration cost drops, automation becomes accessible to mid-sized suppliers, not just large OEMs with dedicated IT teams, and the modularity piece is equally important. The slide graphic shows how the architecture of 1751 is in the envelope. Every other standard in the family is a module that plugs into it. So it's a single file that carries material data, lab reports, conflict minerals, process chemicals, and traceability information simultaneously. You declare once, and your customer receive everything they need. Think of it as the common container. I think Harris and others mentioned this as a container or an envelope that defines trading partners, exchange information, identifies who's sending the data, who's receiving it, what product is being referenced, and the metadata associated with the request or response. The sectional standards define the specific business content being exchanged. This approach allows for new data domains to be added without changing the overall exchange framework. And talking about exchange framework, we are also in the works of building something similar to Semiconductor X, which is Electronics X. So that is also part of where we're going next. Now, the 1751 standard defines the data elements of the data exchange envelope. The sectional standards then do all the data sets that may be transmitted within the same envelope. The structure also supports complex products and assemblies through parent-child product relationships. This is especially critical in PCBAs because you're not just looking at the component, let's say the PCB itself, but you're looking at every single component, and within those components also maybe stacking materials that are used or other things that are play into the full assembly model. As regulatory and customer requirements continue to expand, the framework allows you to have new sectional standards to be added while preserving the compatibility. with existing systems and data exchange. The architecture is increasingly being leveraged beyond traditional compliance reporting. So this is not only, and this has not been used only for compliance. It has historically, at least for 10 years now, has been used for customer requirements, meeting your customer demand, being that having those suppliers that do bring up the necessary information that customer needs. Now, upcoming standards that are coming, the next revision of our long-standing traceability standard, 1782, which is a widely adopted standard in the aerospace and defense industry for materials and process traceability. These are we're finalizing the JSON schemas for this one and ensuring point-to-point and clear requirements, building a supply chain risk, which is built on a supply chain risk management system. An upcoming revision also to our cybersecurity reporting standard is IPC 1792, which is not on the screen, but I care to mention it. It's a standard for a trusted, validated, secure supply chain, answering to the paradigm shift of defense to resilience. The resilience-oriented security concept, which means to withstand, detect early, and recover fast. And last but not least, a brand new standard being added to our library for CO2 reporting, the 1783 CO2E, data collection for reporting of CO2 emissions for the electronics manufacturing supply chain, enabling expansion beyond just PCB and PCBA, which is what's defined for, and supporting, of course, GHG compliance metrics and including a trusted data quality assessment. So remember this, 1751 is the foundation, the envelope that carries all the other sectional standards from materials, lab reports, aerospace substances, conflict minerals, manufacturing processes, process chemicals, packaging, etc. 1752 is your traceability layer, the unbroken chain of custody from a raw material to a finished product. And then 1783 adds the sustainability reporting layer, which is your product level carbon footprint calculated from your actual process data, being picked up essentially and qualified as primary and secondary data. And because of all of these standards share the same JSON schemas as the 1751 data types, the data flows between them without reentry, without translation, without manual intervention, which is why what we all wanted in the end, have a kind of a total automated system, especially for those teams in large OEMs that are spending hours and days on meeting regulatory requirements. So as a recap today, what I have shown you today is not a collection of individual compliance tools, but rather a framework itself. It's a connected set of standards that share a common data architecture and are built on each other. This is integrated because standards are designed to work together. It's secure because JSON schemas validate data ingestion, so garbage doesn't make it through. And it's interoperable because every trading partner using the standards exchanges data in the same format. It's validated because the schemas establish a baseline for what correct data looks like. It lowers the risk because structured data means faster compliance, fewer errors, and cleaner audit trails. And data quality is assured because standards like 1783 include explicit quality scoring built into the reporting model. So this is a digital thread, and these standards are its backbone. And that's all I have for today.
Thank you so much, Francesco.
I try to keep it as short as possible. I'm sorry.
It was very clear.
Yeah.
Very, very clear.
I think I have a question. Yeah.
There's a question from Julia in the chat. We're waiting for IPC 1753 new revisions in some years now. Where do we stand?
53?
53, yes.
Okay. So 53 is not being, well, it just came out, sorry. So 53 should be available in the store anytime now, together with the JSON schemas. These are one of the 4 that has been, or the 5 actually, that has been updated to the latest revision. The lab reports, you mean, right? So yes, this has been recently updated and is now part of the new set of declaration standards, supplier declaration standards.
I think you made Julia very happy.
Yeah.
I don't. So now a question for Moritz. Do we have time for Q&A? And can people unmute themselves, or they may not be able to unmute themselves?
I guess we are already over time, but let's
Yes.
take maybe another 5 to
Yes.
10 minutes. I hope that's okay. We would need to check with Arnaud if they can unmute. Otherwise, they're very welcome to write their questions into the chat, and yeah, we can take them.
Indeed. And so if any participants have any question, please write your question in the chat. In the meantime, I was listening to all the presentations, and I'm talking to all the speakers. So Catherine, Chiara, Marc, Aris, Francisco, and I think that we have a lot of work to do together. I think potentially. I was just noting down ideas for, where we can collaborate and where we can build synergies. And I was thinking that what may be the next step forward for us would be more like a workshop mode, meaning on ideas where we can actually work together and build on each other's work. And I don't know if this would be something that you would be up for. For example, I think that one of the things I heard today, especially from Francesco, it's you use the term we have interoperable data because we have a JSON schema, but that means only you have interoperability on the technical point of view, syntactical point of view, right? That doesn't mean you have semantic interoperability. So I think that we can I think that would be very interesting to work together to bring your standards to a higher level of interoperability, and therefore work to, for example, combine standards or data that is provided by RBA or by Semiconductor X, and vice versa with the data that is generated using IPC standards, right? I was thinking, I noted there was an IPC 1782 and 83 version for environmental declarations, and I was wondering how compatible is that with RBTP presentation by Catherine for digital conformity credentials issuing according to such a standard, right? So there was a lot of these things where I saw links between presentations and where because I think that one important thing is that what we're aiming towards is not some form of global harmonization. Everybody uses the same kind of standards. Everybody uses the same tools. Everybody uses the same schemas. I don't think that this is what we're working towards. I think what we're working towards is that whoever is making it possible to have interoperable data about anything, facilities or attestations or conformity credentials or products or boards or components, anyone who's making data available for reuse by others can do so and make it easy to be reused by others, whoever needs to use this data.
Yeah,
And
that is I fully agree with you, and this is how, at least this is how we drive our standards being created. These are, our committees are made of volunteers from industry, people that are in, in other working groups in other places as well. They're open to industry. They're free to join. There's no really limit to what you can do there. I mean, as a committee member, you can join, and on a voluntary basis, of course, and have those discussions. And these are the arena per se where things happen in our end. But nevertheless, we have an ongoing relationship, for instance, with RBA, working on several different projects. We have relationships with JDEC for components. We have relationships with IC for different things. We have relationships with we develop standards and things that can kind of bring the world together. I mean, in the end, it's our it's our mission, right? So we're not
Right.
excluding anyone. On the contrary, we want to make sure that, you know, potentially if electronic X, there's a thing that Harris showed, ChemX, semiconductor X, so many X's, right? And we are actually working on this electronics X. I'm thinking, okay, this should all be, the concept itself is brilliant. This decentralized approach is brilliant. I couldn't agree more. And this should be all in one, right? Kind of, that's the way that I end up looking at it as a personal, from a personal standpoint.
Mm-hmm. Well, more precisely, I would love to see an IPC standardized JSON reused in the semiconductor ecosystem and vice
Yeah.
versa, right?
Yes.
This is
of
the kind
course.
of things that we want to see. I'm happy to know that you and Catherine already have collaborations, and I'd be interested to see what you're collaborating on exactly on the was it on the digital
Definitions.
facility?
Yeah.
So we could talk about this at length in another
Yes.
in
Yeah.
another context, I think.
Yeah.
But I do
Yes.
hope that this is just the starting for a more intense conversation on what we
I
could do together.
I hope so too. I think there's a lot of different actors and different things happening,
Mm.
and there's a lot of room for everyone, right? So I don't, see why not. And we're always open for discussions and cross collaborations against within different industries. And I'll give you an example. We developed 10 years ago a common connected factory exchange data protocol that allowed for machines within the manufacturing site to talk to each other, right? This was done by the Hermes consortium, and we developed it even further, taking it into a centralized point so that you can actually track down or collect data directly from the machine, and regardless of the brand. And we got all the materials, equipment suppliers basically together, and we said, okay, this is what we need. This is what industry needs, and it's working. It's been working for many years now, and this is kind of the approach that we have to industry.
Mm-hmm.
We tend to bring people together. That's our job. So yeah.
Yeah, exactly. This is why I'm so happy to bring standardization activities to this work, because we need to move beyond the pilots. There's pilots and pilots and
Yes.
pilots all over the place, but none of these pilots can get traction unless there are industry backed standards and a desire for adoption. And this has to do with Robson's question in the chat. We see many pilots and projects. Yes, and that's the problem. How industries should look at you in order to adopt those ways of working you are showing, offering, or proposing. Is it going to have the convergence of all those projects into a single DPP standard aligned to the definitive delegated act? Who is going to orchestrate that? So I don't believe in some form of global DPP orchestration.
No.
There are global DPP standardization activities
Yes.
in the W3C, in ISO, in ISO IEC, and that's
Yep.
great. But there will not be global orchestration. And the beauty of decentralized interoperable data is that you don't need global orchestration.
Exactly. I don't think
You,
it's needed. Yeah.
you don't need it, right?
Mm-hmm.
But we do need the data to be issued in using interoperable formats, and I'm not just talking about syntactical interoperability. I'm talking about semantic interoperability. And so
and value.
a
The
value,
value.
you mean that there needs to be value for doing it, meaning that
Yes,
Well,
semantic, for example, let's say the methodology, let's say the carbon footprint, for example. You have the PAC methodology, you have one
yes.
which is from the DTA, Catenix. So we need the methodologies, it brings the calculation methods for the value, and it should be the same ideally, because if not, you'll have different values depending on the methodology, and that will make it really complicated.
that is the
Well,
biggest issue in CO2. That's correct. Yeah.
well, yeah.
Yeah.
Well, this is a different conversation, agreeing on what the values mean. But whatever the methodology you choose, you can create data for that methodology as long as the metadata accompanies the data. That way, you know how,
Yeah.
if you can use that value at all, or if it makes sense for you to use it in your system or not, right? So it makes semantic interoperability brings this capacity to question if a data that you've retrieved you can reuse in your context or not, right?
Mm-hmm.
So I don't think that there will be global agreements on how to calculate CO2 footprints ever. That will not happen because there are too many different ways you could do it and reasons for doing it that way. But the important thing is having interoperable formats where whatever method you choose, there's the data that accompanies it, which allows you to understand if that using that information makes sense in your system. Am I clear here?
Yep.
Yep.
Harris? Yeah. Okay.
Yeah,
So I
absolutely.
would like to see an IPC, DPP, or you called it a declaration, a supplier declaration. I would like, so this kind of, you could say a supplier declaration is a DPP
It
of a
probably,
supplier.
yeah,
Okay.
you know, 10, 15 years ago, it was supplier declaration. Today, probably they call it DPP because it's
Exactly.
essentially that, right? But yeah, it's knowing, and this is especially critical, and knowing what's in your components and your assemblies is especially critical for recycling. If we are, even for reuse, we are developing documents for component recovery as well. I mean, it's not, these things are happening. It's just we need to know, and this is especially critical, the full material declaration needs to be there, whatever, for the end of life purpose, right? Because in the end, resilience is not just about being able to act fast and also to retain those materials in the same region, right? This is how you regain that sovereignty that you need, especially for Europe, for instance, since I live here. So yeah, but other other regions as well, their sovereignty relies on, so that e-waste is actually far more let's say valuable than a lot of people tend to think of it.
So
And
globally, I would
if I
like to
come,
see. Go ahead, Harris.
yeah,
Yeah.
if I come back to your question, Caroline, because you're actually trying to make it hands-on, the whole thing, you were asking, okay, how does the SME does it when it comes with an Excel sheet? And to me, that's really the question to solve, because we're on a very theoretical path, and we were speaking about use case, and I see the question from Robson as well, which means what we're doing actually is for SME, it looks like nobody knows how to do it, doesn't know the format, the EU doesn't know what will be inside, but we have to be ready till 1st January 27.
Yes.
And Caroline was saying, okay, how do we do it? And I was thinking about that last week. And the question is, could we do a kind of hands-on? Because the European Union is as well waiting for the industry to propose formats and contents. And the question is, if we could take yes, part by part, take a PCB, take a chip, take a pump, take a mixer, and just make a so-called voluntary preliminary DPP. And make it hands-on, put it on the website, and show it actually, because when you see the, let's say, the final JSON and the different possibilities in JSON LD and asset administration shell, you really can use it. And for IT people, it's easy to implement something when you see it practically as when you run through.
Well,
Let's say,
both
I am
Catherine and
now.
Marc. Marc, I don't know if Marc, you showed some examples from your platform, but Catherine showed some real examples, and I've seen some real examples from Marc from the Data Peanuts platform. So there's a lot of things to show that are very hands-on already, Aris.
Yeah, perfect. So let's put them together.
Let's put them together. I would like to see the Semiconductor X using a DPP issued according to an IPC standard linked to a facility record from RBA. This is what
Yeah,
we
that
need to
sounds
see.
good.
Let's do that. Okay, that's what we need to see.
Okay.
And
I
somehow
accept the
this has to
challenge.
be linked to. Okay.
Let's make it happen. Yes.
Exactly.
Let's
And
make it happen.
then we connected to semi.org and to Catena, and step by step we got
Yeah.
them all.
Exactly.
Yes, exactly. So we have some work to do, but all right. Thank you so much. I think we're going to end here. Thank you, Marc, for showing posting the link to your platform in the chat. Thank you to all the speakers. Thank you, Moritz, for being our host, for coming and representing EECONE. Thanks to all the attendees. And well, we hope to be in contact soon with the follow-up to this. So I see Robson is asking some textile questions in the chat, but I will not answer this right now because we're going to close this conversation. Thank you so much for attending. Goodbye.
Thank you very much, Carolynn. Thank you, everyone.
Thank you for the invitation. Bye-bye.